Let's do this question. 15 candidates are being ranked according to their performance. What is the probability that the rank of person 1 is above the rank of person 12? None can have the same rank. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now, this question is a probability question that uses some concepts that we have discussed in restricted permutation. So refer restricted permutation to get a deeper understanding. Alright, over here we have 15 candidates. Let me mark them as P1, P2 up to P15, right? And it is mentioned that we need to arrange them such that the rank of person 1 should be above the rank of person 12. Alright, now 15 people, when I rank them, I will need 15 places. Now, let me pick any 2 places out of these 15 places, which can be done in 15C2 ways. Alright, and once I have picked 2 places, for example, I pick this place and this one over here. Once I have picked these 2 places for person 1 and person 12, there is only one arrangement which is possible, right? Because person 1 has to be above person 12. Therefore, I have to put person 1 over here and person 12 over here. There is no other way, right? So, among these 2 places for person 1 and person 12, there is only one arrangement possible. And I am left with 13 more people and 13 more places. So, 13 people in 13 places can be arranged in 13 factorial ways. Therefore, the number of favorable instances is 13 factorial into 15C2, right? That's these two numbers multiplied together. And we know that probability is favorable by total, right? So let me keep this aside. We know probability is favorable by total. Now we have 15 places and 15 people. So 15 people can be arranged in 15 places in a total of 15 factorial ways, right? Therefore, probability is equal to favorable by total, which is 13 factorial into 15C2 divided by 15 factorial. This can be simplified as 15 into 14 by 2 by 15 into 14, which is equal to 1 by 2. A different way of thinking of it is you could directly arrive at this answer thinking that in all the arrangements, in half of the arrangements, 1 will be above 12 and in half of the arrangements 12 will be above 1. Therefore, the probability is 1 by 2. That's a logical way of approaching the same question. Let's do this question. A mother gave her children some chocolates. Each child got less than 6 chocolates. What is the probability that the sum of the chocolates with both the children is more than 4 but less than 8? Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Let A and B be the 2 children. It's mentioned that each of them got less than 6 chocolates, right? And we need to find the probability that the sum of the chocolates with both the children is more than 4 but less than 8. So what are the possibilities? A plus B could be equal to 5, right? It's more than 4 but less than 8. Or it could be A plus B equal to 6, or it could be A plus B is equal to 7. If A plus B is equal to 8, it will violate the condition. So these are the 3 possibilities which we need to explore. Alright, it's given that A is less than 6, so A can be 0, 1, 2, 3, 4 or 5, right? Similarly, B also can take values from 0 to 5. Now, therefore, let's draw a 6 by 6 grid where each of these values are 0, 1, 2, 3, 4, 5, which are the number of chocolates with A. We can see that they can be 0, 1, 2, 3, etc. up to 5, right? Similarly, the number of chocolates with B also can be 0, 1, 2, 3, 4 or 5. Alright, now let's try to mark A plus B is equal to 5 in this grid over here. That would be these points, right? Over here, A has 5 chocolates and B has 0 chocolates. Over here, A has 4 chocolates and B has 1 chocolate. Similarly, over here, B has 5 chocolates and A has 0 chocolates. So in all these instances, that's 1, 2, 3, 4, 5, 6, sixth instances, a plus b is equal to 5. Similarly, let's mark a plus b is equal to 6. That would be these instances, right? Over here, a has 5 chocolates, b has 1 chocolate. Over here, for example, a has 3 and b has 3. And over here, b has 5 and a has 1. What about a plus b is equal to 7? These are the instances where a plus b is equal to 7. A has 5 and b has 2, or a has 4 and b has 3, a has 3 and b has 4, and b has 5 and a has 2. Alright, so what are the favorable instances? Over here we have seen that 1, 2, 3, 4, 5, 6. We have 6 cases over here. What about here? 1, 2, 3, 4, 5. That's 5 cases over here. And in the case of a plus b is equal to 7, we have 1, 2, 3, 4. 4 favorable cases. Therefore, the total favorable instances is 6 plus 5 plus 4, which is equal to 15, right? And what are the total possibilities? A can take, you can see 6 values, right? 0, 1, 2, 3, 4, 5. That's 6 values. Similarly, B also can take 6 values. Therefore, the total possibilities is 6 into 6, which is equal to 36, right? Now, the probability is favorable by total, which is equal to 15 by 36, which is your answer. Let's do this question. In a game between two games, a team can get a maximum of 10 points. Find the probability that the two teams together will get more than 6 points but less than 11 points. Alright, pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Over here it's mentioned that the maximum points that can be obtained is 10 points. Let the two teams be A and B. Therefore, A is less than equal to 10 and B is less than or equal to 10. Over here, remember it's less than or equal to because they can get 10 points also. Now, what are the different possibilities such that they get more than 6 but less than 11 points? A plus B could be 7, 8, 9 or 10. So these are the 4 possibilities which we need to explore. Alright, now any value over here, A or B, can take the values from 0 up to 10, right? Therefore, let me draw a 11 by 11 grid over here, and these values are 0 to 10, and this is 0 to 10. These are the values A gets and these are the points B gets. Alright, now let's explore A plus B is equal to 7. Over here, if A plus B is equal to 7, you can see that there are 8 favorable points. 1, 2, 3, 4, 5, 6, 7 and 8, right? Over here A gets 7 and B gets 0 points, or over here A gets 3 and B gets 4 points. Similarly, in all of these cases, the total points obtained by the two teams is equal to 7, and we have seen there are 8 such points. What about A plus B is equal to 8? You will see that there are 9 such points. A plus B is equal to 9, there are 10 such points, and A plus B is equal to 10, there are 11 such points. Therefore, the answer to this question is 8 plus 9 plus 10 plus 11, which is equal to 38. 38 divided by 11 into 11, because A can take 11 values, right? That's 0 to 10, which is equal to 11 values. Similarly, B also can take 11 values. Therefore, the answer is the probability is favorable by total, which is equal to 38 divided by 11 into 11. Let's do this question. When 3 dice are thrown simultaneously, what is the probability that the sum of the 3 numbers is equal to 11? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. For this, you can refer the section on grouping in permutation and combination. Alright, let's move on. We know that probability is favorable events by total events. Now, over here we have 3 dice. Let me call them as A, B and C, and we need to get the sum equal to 11. That is A plus B plus C is equal to 11. Now, because we are throwing dice, each of these values has to be greater than or equal to 1 and less than or equal to 6, right? Because 1 is the least and 6 is the maximum value that any dice can get. Alright, now let's start with the lower limit over here. let me give 1 to A, B and C. So after distributing 1 to each of these 3, I consume 3 items. So 11 minus 3 is equal to 8. I'm left with 8 items. Now do remember, if you are not getting this part, refer the section of grouping under permutation and combination so that you will be able to follow this. So this is an application of permutation and combination in a probability question. Alright, let's move on. Over here, I have 8 more items, right? And these 8 items can be given to 2 people. So I have 8 dots and I have 2 lines, right? Because if I have 2 lines, I divide these 8 dots into 3 sets. So that's a total of 11 items, of which 8 are of one type and 2 are of one type. So this can be distributed in 10 factorial by 8 factorial into 2 factorial ways, which is equal to 10C2. Now, over here, we have an upper limit also. So to find the answer, we need to find 10C2 minus the violations, right? So we need to do 10C2 minus the violations. What are the violations? The violations are obtained when any value gets a value greater than 6. Alright. Now let me call these 3 as A, B and C. That is the values after giving 1 to each of them. Now we know that A plus B plus C has to be equal to 8, right? And A, B and C has to be less than or equal to 5 because each of these has already got 1, right? A, B and C has to be less than or equal to 6. If you subtract 1 from capital A, you get small a. If you subtract 1 from capital B, you get small b. If you subtract 1 from capital C, you get small c. Now, because we have already distributed 1 to each, now to satisfy this condition over here, A, B and C in small letters has to be less than or equal to 5. Alright. Now, let's find the violations. To find a violation, let me allocate 6 to this A over here. And I am left with 8 minus 6, that is 2 items, and I have 2 dots and 2 lines, right? Because I have to divide it between 3 people. So 2 dots and 2 lines, that's a total of 4 items. 2 are of one type and 2 are of one type. So this can be distributed in 4 factorial by 2 factorial into 2 factorial ways, which is equal to 4C2, right? Now, therefore, the violations are 4C2 into 3, right? Because the same 6 could have been given to B and to C. So the answer is 10C2 minus 4C2 into 3, which gives you the answer as 27. And that is your answer in terms of the ways in which this can be done. So the favorable ways is 27. Let's also see this just for our understanding how these 27 distributions would be, right? Now, if you have 3 dice A, B and C, these are all the possible ways in which you can get a sum of 11, right? Let me keep 1 over here and I need 5 and 5. Or I keep 1 over here and I can get 6 and 4. The total is 11, right? And let me keep 2 over here and I would need 9 more points, that's 6 plus 3, or 2 over here and 5 plus 4. That also gives me 11. I can have 3 over here and 6 and 2, 3 over here, 5 and 3, 3 over here and 4 and 4, right? Now 3, 6, 2 is a repetition of what we have over here. So we strike this out. Similarly, with 4 over here, I can have 4, 6, 1, 4, 5, 2 and 4, 4, 3. These are repetitions because 4, 6, 1 is already available over here, right? 4, 5, 2 is already available over here and 4, 4, 3 is available over here, right? Because we are trying to do the various arrangements of each of these, right? Similarly, 5, 5, 1, 5, 4, 2, 5, 3, 3, 6, 4, 1, 6, 3, 2. These are all the ways and these are already covered in the previous arrangements. Now let's see one by one. 1, 5, 5 can be arranged in 3 ways, right? I could have 1, 5, 5. I can have 5, 1, 5 and I can have 1, 5, 5, 1. So these are the 3 ways which I have written 3 over here. Now similarly 1, 6, 4 I can have it in 3 factorial ways because it's 3 different items in 3 places. They can be arranged in 3 factorial ways. That's the 6 over here. What about 2, 6, 3? You have 3 different items in 3 places. It can be done in 3 factorial ways. which is equal to 6. What about 2, 5, 4? Again, that's 6 because it's 3 items in 3 places. 3, 5, 3. This can be arranged in 3 factorial by 2 factorial ways, which is equal to 3. And 3, 4, 4 can also be arranged in 3 factorial by 2 factorial ways, which is also equal to 3. Now, if you add all of these, you get 3 plus 6 is 9, 9 plus 6 is 15, 15 plus 6 is 21, 21 plus 3 is 24, 24 plus 3 is 27. That's the 27 which we obtained over here. So, following this method, we do it much faster and we avoid making careless mistakes. Alright, let's move ahead with the question and find the probability. The question says we need to find the probability such that the sum is equal to 11. We have found that there are 27 cases in which the sum will be 11. Now probability is favorable by total. So favorable is 27. And what is the total? The total is 6 into 6 into 6, right? Because we are throwing 3 dice. Each dice can have 6 possible outcomes. Therefore, dice 1 and dice 2 and dice 3 can have 6 into 6 into 6 possibilities. Therefore, your answer to this question is 27 divided by 6 into 6 into 6.